All right, today we're going to cover chapter 21, which is nutrition and metabolism, but we're only going to cover a very, very few pieces of this chapter, so most of which you should have covered already in your fundamentals portion of nutrition. So it's just a few slides. It should only take us a few minutes to cover these specific sections. First, after the digestive system breaks food into usable food components called nutrients, they are absorbed into the bloodstream. So we talked about all that process kind of up until they were absorbed in the bloodstream. The nutrients enter cells and undergo chemical reactions called metabolism. It's through the process of metabolism that nutrients are transformed into energy or materials the body can either use or store. As shown here, some body systems demand a greater supply of energy than others. Liver, brain, muscle, those are big energy users. This should hopefully be a review as well, but I wanted to just mention it again. Energy expenditure is measured by the output of heat from the body. So calorie is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. Usually calorie, when we use the term calorie, excuse me, we're actually talking about a kilocalorie, which is 1,000 times this. So when you see calorie with a capital C and what we kind of normally talk about as calorie, it's really a kilocalorie. And it's 1,000 times this, just like, a kilometer or anything like that in the metric system. Calorie really is the energy that the body uses as fuel. Basal metabolic rate is the amount of energy the body needs at rest. There's lots of different things that affect this: anxiety, fear, eating, thyroid hormones, physical activity. Not only affects basal metabolic rate, but also affects the calories we need. In order to maintain weight, calorie intake must equal calorie output. If not, we either gain weight or we lose weight. So here's some other factors affecting metabolic rate: body size and composition. So people who are larger or have more muscle mass burn more calories, so they need more calories. Males tend to have less body fat and more muscle than women of the same age and weight. Consequently, they burn more calories. And age, muscle mass declines with age, slowing the metabolic rate. Metabolism, we have catabolism and anabolism. Catabolism breaks down complex structures into simpler ones or into energy, and anabolism actually forms complex substances out of simpler ones. So they're opposite things. Catabolism is used in the metabolism of carbohydrates and lipids, and anabolism is used in protein metabolism. The last piece here really that we're going to talk about is thermoregulation. Most of the body's heat results as a byproduct of the chemical reactions occurring in cells. Body temperature normally fluctuates about 2 degrees Celsius, usually lowest body temperature in the morning. And that's follows our normal kind of circadian rhythm. We have 3 main methods for heat loss: radiation, the transfer of heat through the air by electromagnetic heat waves, example standing in bright sunlight; conduction, the transfer of heat between 2 materials that touch, so sitting in a seat someone just vacated, or leaving a spoon in hot soup. The spoon then will get warm, or you can actually feel when you sit down in that seat that somebody else has transferred heat to that seat. Evaporation requires heat to change water into gas. So evaporation is what happens when we sweat. So we get moistness on our skin, it evaporates, and it cools our skin. We have a negative feedback mechanism that regulates body temperature. The hypothalamus acts as the body's thermostat. It monitors the temperature of the blood and sends signals to the blood vessels and sweat glands. When the body's temperature is too high, the hypothalamus signals the cutaneous blood vessels to dilate. More warm blood flows close to the body's surface, and heat is lost through the skin. If the temperature remains high, sweat glands produce sweat, and the evaporation of sweat produces cooling. When the body temperature falls below normal, the hypothalamus signals cutaneous blood vessels to constrict. Instead of flowing to the skin, warm blood remains confined deep in the body. As a result, less heat is lost through the skin. If the temperature remains below normal, the body begins to shiver. Muscle contractions associated with shivering release heat and raise the body's temperature. So we have a negative feedback system here controlled by the hypothalamus. And that really covers just a couple of small pieces that I wanted to talk about in chapter 21.